Hi everyone. Today in this tutorial we will be demonstrating how we can use text to audio LLMs. Basically we'll be providing with some text, some features also like laughter, some expressions, and eventually we'll be able to see that how the LLM is able to use them and eventually create an audio which performs all those actions also alongside alongside the audio conversion. So let's get started. So first of all, we need to pip install this particular Git repository, that is Bark. This is the URL github.com sono-ai bark.git. Don't go for a pip install bark because it installs a different package. So you need to go through this git repo URL. Once you're able to do it, you will be in pip install. We will be importing a few packages from Bark, SciPy, and IPython.display for audio purposes. So basically, we will be getting an audio file instantaneously. So we'll be listening to that also. Then we'll downloading and loading all the models present. Preload underscore models functions. Once you are able to do, as you can see there, next we'll move on with the demonstration. So I'll be showing you three demonstrations. The first one is that we are writing a text. This is Mehul, clears throat. I am a data scientist, chuckles. What about you? So here you can see that I have mentioned what audio I want, that is man. Then I have mentioned some expressions also, clears his throat, chuckles, and all that stuff. The second thing is that generate audio, where we're passing this text prompt, and the history prompt equals to v2 forward slash d underscore speaker underscore 2. So basically, in Bark, you get options for multiple speakers also. Like you want a German guy, you want a Portuguese guy. So this is basically a second male voice for German. So if you go to the Bark Git repository, there you can see all the options and the code for each of the options. So once you are able to do that, it is able to generate an audio array. We'll be writing this audio array using write underscore wave if you wish to save this audio, sample and audio array, and this is the audio if you wish to play. So as you can see that audio array actually has our audio, so we'll be listening to this audio and you will see how actually it is following all the instructions present in the prompt.
This is Mio. I am a data scientist. Ah, what about you?
So as you heard in this demonstration, it was clearing his throat also in between and chuckling after the sentence. So this is quite amazing. The next prompt is like we can also make it sing. So if you mention this particular two symbols at the starting and the end of the sentence, the prompt will be taken as a music piece, and eventually uh, here you can see that we are again generating an audio, but just providing these two extra symbols. And this time we are generating a French voice, that is the code FR.
Der gefordert. Vorbrater said,
So in this demonstration, you saw how the female voice was trying to sing the text rather than just speaking it. So this is just a demonstration. You can improve this. And the final one being, so basically in this particular basic demos, you can't generate an audio greater than 13 or 14 seconds. So for generating an audio greater than 13 or 14 seconds, we need to do some side work as well. So here you can see that we are importing some NLTK packages, NLTK.download, punkt, and we are also importing some extra packages from Bark. So this time, what we're trying to do is that we're generating an audio for the whole paragraph. As a professional athlete, I have already believed in giving all the game of the cricket. So basically, it's a retirement speech for some of the players. So as you can see, the length is quite good. It's 6 sentences. So we will now try to generate an audio for all these 6 sentences. So if you follow the previous demonstrations, you won't be able to generate an audio for this long a sentence. So you need to have so here you can see that we are first of all, so the whole idea is that we are first of all taking the prompt, we are sentence tokenizing it using NLTK, and then eventually for each of the sentence we are generating the audios one by one and then appending these audios, nothing else we are doing. So also in this time, what we are doing is that we are also adding pieces of silence between the sentences so that a person can check out whether the sentence is ended or not. So this will look very genuine, and let's get started. So once we are able to sentence tokenize the whole prompt input, here you can see that we are generating audio for each of the sentence one by one. We have provided an English speaker, and then we are add appending all these pieces, and finally we have generated an audio, so 1.4 minutes. So this is pretty long. This you can't generate using the default demonstration. So we will now listen to this whole audio that has been generated for the whole paragraph.
As a professional athlete, I've always believed in giving my all to the game of cricket. It has been an incredible journey, one that I've cherished with all my heart. However, I've come to a point in my career where I feel it's time.
So as you heard that we are able to generate long audio for long sentences also using Bark. So in this demonstration, we saw how you can add expressions, how you can make the audio sing, and eventually you can generate audios for very long sentences also by sentence tokenizing. And also this is how you can generate prompt and convert your prompt into audio files using Bark.